We're studying IGCSE mathematics and we're starting trigonometry. Now this is a revision of trigonometry. We'll be studying everything from whatever you have in your syllabus, Pythagoras Theorem, finding angles, area of a triangle, the trigonometric functions, trigonometric graphs, sine rule, and cosine rule. These two as well. That is all you have in trigonometry. That's your complete book. Okay. Now, if I try to solve this, let's start with Pythagoras theorem. Okay. Now, Pythagoras.
I have a question.
Yeah, ask me.
What are the other things like tan and the cos? I think
That's here.
COS.
Trigonometric functions. Tan.
Oh, okay.
So it's actually so. We'll do this afterwards in a second. Okay, we'll do this in a second. We'll start with Pythagoras theorem first. Now, the sine, cosine, tan, that's the trigonometric functions. This S stands for sine, C for cos, T for tan. Okay. Now let's start with Pythagoras theorem. Now for that, I'll use this diagram right here, bring it down, and let's start. Now Pythagoras theorem tells us, let's say if I want to find the height, if I want to find the height of something or the length of something I don't know, I can use the Pythagoras theorem, but it only works for right angle triangles. What kind of triangles? The right angle triangles. Now this right here, this square shape tells us that this is 90 degrees. And what kind of triangle is this? It's a right angle triangle. Now let's say if I tell you, before I tell you anything, let's just say what is the Pythagoras theorem. Now the Pythagoras theorem is that this c squared is equals to a squared plus b squared. Now a in this case is this side, b is the height, and c is the hypotenuse. Now I can say this as hypotenuse. I'll write it down right here. Hypotenuse or hypotenuse, however you want to pronounce this. So the hypotenuse is C. On the other hand, A are the other sides. Let's say base. Now we won't be using the word base or height in our classes, but this is just to tell you that a triangle has a few parts to it. It has a base, it has a height. Okay, but the most important aspect is the hypotenuse, this one. That's always hypotenuse squared is equals to the other sides a squared plus b squared, whatever the other sides are, right? If in this case it's a base squared plus height squared. Now it doesn't matter. All you need to know is always take C as the hypotenuse. The other, so it will always be c squared plus a squared plus b squared. Let's see. Let's look at a question. Now the first question is, if I tell you that this side, this is your right angle triangle. Now this is, let's say 5, and this is 10. Now you have to find this. How do you find it? Now let's first. Yeah.
You do a squared plus b squared, and then you get c squared, I think.
C squared, yes, exactly. So c squared is equal to a squared plus b squared. Now what is c in this case? C is always the hypotenuse. Now which is the hypotenuse? Which side is the hypotenuse? X. Why is it the hypotenuse? Because it's also the longest side.
Oh, okay.
So the longest side is your hypotenuse. Longest side. Okay. Fine. So therefore we know that x squared is equals to 5 squared plus 10 squared. Okay. So what is x? X is going to be 25
plus
25
100.
plus 100, and then x is going to be
125.
under root of 125.
The root?
Under root, yeah, square root. We take the 2 to the other side. Now what happens is, now when you add these two numbers, you
Okay,
get
I
x
get it, I
squared.
get it.
Now x is under root of 125.
Yeah, I get it. All right.
Yep. Okay, so what is the answer? Tell me.
I don't know.
So you don't have to
125.
try. So it's going to be under root. So it's going to be about.
Can I use a calculator?
You can do with a calculator. I'm just telling you right now. Do you have a calculator with you?
No.
No, so never mind then. I'll do it for you. Now, so the answer is 11.18. Now, can you see the calculator on the screen? Just a second.
No, I don't.
Not yet.
All right.
Okay. 1 second. Now you should be able to see it. Can you see it?
No. Yeah.
Now you can. Fine. Now on this calculator, let's just do under root of 125. That gives us 5 root 5 or 11.18. Fine.
All right.
But in the exam, we don't write answers like this. We write answers as 3SF. What is 3SF? Only 3 digits. So 11.2. This is 3SF. Okay. Now next question.
So we just round it up?
We round it up. Yes, round it up to 3 digits.
Oh, okay, okay. So if it was like 16, what do we put? Do we put the same thing?
16. If it was 16, let's say just 16. Then we say 16.0. These are the 3 digits.
No, like if it was 11.16.
11.16. Okay. If it was 11.16, we say 11.2.
Oh,
Again,
the same.
round up. So if it was, let's say 11.14, this would become 11.1. Because 4 is less than 5. Now,
yeah.
in this one, let's say 5, and you have 5. What is x? Now I want you to find x.
Wait 1 second. Is this still the same thing?
Yeah, still the same thing. Try. Tell me, I'll write it for you.
Wait 1 second. Wait 1 second.
Now, what is C? What is A? What is B? The next part is finding C, A, and B. Now, Anas, can you hear me? I don't know. So let's talk about one thing. So I need your microphone on throughout the class. Is that clear? Uh, 10 squared is equal to 5 squared plus x squared. Now 10 is the longest side because we don't look at the number 10, we look at the side 10. Now this length is obviously the hypotenuse, so we take that. Now 10 squared 100 is equal to
1 second,
25.
sir. I can't talk right now.
Therefore, 100.
Yeah, I could talk right now because everyone is like over here. Everyone said my
100 minus 25 is equal to x squared, and therefore if you solve this you get 75 is equal to x squared. Therefore x is equal to a square root of 75. Now let's try looking at the answer. 75, that gives you 5 root 3. I always like to give answers in the exact form, right? Answers in the exact form are much better. So this is 5 under root of 3x. Now, if you want to give the answer in decimal, that's also okay. 8.66. 3SF. Now, there's no specific. There's nothing wrong with giving other answers, but 3SF is just better. Try to give answers in 3SF to have a standard form of answering questions. Now let's look at the another question. Yes, Anas, can you hear me?
So,
Go on, speak louder. I can hear you.
yeah.
Okay, now let's try solving this question. Now, one thing, I don't need your microphone on because of the background noise. Right? It's okay.
So for this, I think you do 5 squared equals, yeah.
Equals? Okay, now what is the next step? So 25 is equals to x squared is equals to 16. Therefore, 25 minus 16, that would give you 9 is equals to x squared. Therefore, root 9 equals x. And the answer is 3 is equals to x. Any doubts in this? I can't hear you right now. Your voice is very low. Try. I can't hear you, Anas. Anas, can you hear me? By the way, Anas, are you free right now?
Yeah, I can, sorry.
Are you free?
Yeah.
Okay, good. Now, so today's class is a bit longer than usual. It will be because we'll just try to finish this and then you can rest. Fine. So question 2. If I say we have this theta right here, and again, you've been given this and this.
So you do sin and then the circle thing, theta. I don't know. I forgot what it was called.
Theta.
Theta.
Yeah.
Theta. All right. The sin and the theta thing, and then you put equal to theta sign.
Yeah.
Sign. Yeah. Sign.
Yeah. Okay. Sine theta. Then after that.
Sine theta. Then you do the 3/5.
Okay, but why 3/5?
Because the theta is opposite to 3, like the 3 is opposite
3 is opposite. Okay. Now what is 5?
5 is next to the angle, I think.
It's next to the angle. That means, is it the hypotenuse?
Yeah.
No, that's wrong.
Hypotenuse.
Wrong. This is correct.
No.
It's not hypotenuse. It's next to the angle, right? The hypotenuse is always the longest one. This side is the longest one.
Yeah.
This is your hypotenuse, not the other one. Now, if this is the hypotenuse, HYP, then this cannot be the hypotenuse. Therefore, if this is the hypotenuse, this is the opposite. This has to be the adjacent. Now, which of these adjacent? You were correct. You said next to the angle. Adjacent means next.
Oh, okay.
So if I change this a bit, I say adjacent. Okay, fine. But which of the trigonometric functions follows opposite by adjacent? Tan, TOA, TOA. Opposite, T is equals to O over A. So opposite over adjacent, this will become tan theta. Is that clear?
Yeah.
Tan theta is equals to this much. Then therefore, what is theta? Tell me the answer. Let's work it out. Now therefore, what is the next step?
You do theta equals tan minus 1.
Inverse.
And then
Tan inverse.
yeah,
What is it? Inverse.
tan inverse. And then you put the 3/5 in parentheses.
Yeah, perfect. And then you solve this. Let's look at the calculator. If you can see it, now you can. Let's see. So tan inverse of 3/5, which is 30.9 degrees.
30.9.
Is it 30.9? No, it's not. Why? Because you round it up.
Yeah.
This will
so
become
40.
30. No, not 40.
Oh yeah, 31.
31.
Yeah, sorry, I read the last number.
It's okay. It's 31.0 degrees. Now, always give this answer to one decimal place. How much?
1 decimal place.
0. Now,
So
if you wrote
the 0.0.
0.0 and let's say the answer was 30.96, 30.96. This is 2 decimal places. That's okay. But as soon as I make it 3 decimal places, it will become 30.10, and then this 1 will come here. Okay.
Oh, okay.
Now, okay. So that's it. Let's look at another question. Let's say, what if you have a question like this? Let's say a question like, just a second. Now, okay, so this is right angle right here. This is 6, and this is, let's say, 12.
Did it give you the theta in the exams?
Which theta? This one?
No, the other one with the circle.
Yeah, they will. That's what they're asking you. Which one is it? So you're supposed to find this, right? It could be this one. Let's say theta 1. Now in this question, we'll find both of these angles, theta 1 and theta 2. How many angles are there inside a triangle? There are 3 angles. If you make a triangle like this, 1, 2, 3. So theta 1, theta 2, theta 3. Now, but the thing is, over here, theta 3 is equals to 90. Always. Is that clear?
Okay.
We'll look at this in a second as well. Let's solve this question. Now tell me, what is theta 1, what is theta 2? Give me the relationships for them.
Theta 1 is the C. No, wait. I don't know.
I'll tell you.
Theta 1.
So tell me first, with respect to theta, this one, is this adjacent, hypotenuse? Which of these? We have 6 and 12. So first step, what is the first step? First step, name sides. Okay, name sides. Now with respect to theta 1. With respect to theta 1. Now if let's say the first theta over here, theta 1. So 12 is what is this? Which side is 12? Is it opposite? Is it adjacent? Or
the hypotenuse?
Hypotenuse, yes. Hypotenuse. Hypotenuse, yes. Okay.
Hypotenuse.
Okay. Now 6 over here. What is 6 compared to theta 1?
6 is the
Adjacent.
something.
Adjacent. Is that clear? Adjacent. Hypotenuse.
Yeah.
Hypotenuse. Okay. Now theta. Okay, we have all of these. So which function will we use? Sine, cos, or tan?
We will use we use tan.
Tan? Not really. Tan has O and A. O stands for opposites.
Wait, so add and then high. We use the cos.
Cos. See, that's easy. Now use trig. Use trig function.
What's trig? Is it cos?
Trig. Okay, whatever trig is let's say applicable in this case. Trigonometry. Trig. So let's solve this. The first one over here, part 1. Let's say for theta 1. So I'll say that cos theta 1 is equals to, what is it equals to?
So wait, 6/12.
6/12. Therefore, theta 1 is cosine inverse of 6/12.
Yeah.
Now, what is cos inverse of 6/12? Let's see.
We don't simplify it.
We can, yeah, that's what I was thinking about. Let's simplify this. Now, 6/12 can be written as 1/2.
Yeah, 3/1/2. Yeah.
1/2. So 1/2. So what is cos inverse of 1/2? Same thing. The answer won't change. It will be the same. The answer won't really change. But let's see. So 6/12 is 60 degrees. Is that clear?
All right. We don't put the decimal point.
Oh yeah, we do. Yep, we do. Good job. Okay, that's 100%. That's so you are paying attention. That's amazing. I like that. So question 4. Wait, we haven't done theta 2. So tell me, what is theta 2? Relationship for theta 2. But before we do that, we'll have to change the names, because now the names are with respect to theta 2. So let's say we'll use the different color. Let's use blue for theta 2.
So the 6 is
6 is
opposite. So
opposite. And 12 is?
And then 12 is adjacent.
No, not adjacent. No.
Isn't it it's the longest. Wait, so it's hypotenuse. Yeah.
Still hypotenuse. So the hypotenuse will not change. It will still stay the same. Yeah. Right? Adjacent would be this side, because that's not the longest, but it's next to it. This is next to this guy. But this is the longest, so that's hypotenuse.
Isn't that also next to, like? It
is next, but it is also longest. So we're looking for the next, which is not the longest. Okay?
All right.
Right? If it's longest, it must be hypotenuse. Now, what is the other next? The other next is the adjacent. So let's see. So in this case, we don't know the adjacent number. It's not given the length, but we do know these two guys, opposite and hypotenuse. So which of these will we use? Sine. So sine theta 2 is equals to 6/12.
Yeah.
So theta 2 is equals to sine inverse of 6/12. 1/2. Which is, let's do it here, sine inverse. That gives us 30 degrees. Now, before we move on, any doubts in this?
We do 30.0, right?
30.0 again. Good job. Yes. Now, in this case, any doubts so far?
No.
Easy. It is easy, right? Right? Yeah. That's what I'm saying. So when you learn something, it will become easy. When you practice, this will be nothing, 3 marks. Trigonometry is 3 marks in the exam. Okay, let's see. One thing you need to know is sine 60, sine half, sine inverse of half. Sine inverse. Sine inverse of half is always 60. 30. Okay. Always. And
30.
And cos inverse of half is always 60. Now you have to memorize this. So if sine inverse of half is 30, then can I say sine 30 is half?
Yeah.
Yeah, and in the same way, if I take cos to the other side, cos inverse, it will become cos. So cos 60 is half. But I want you to memorize this part. This.
What about the tan? Is it same for the tan? Like, is there like a specific answer for the tan?
Yes,
When
exactly.
it's
There is. So tan inverse of half is 45.
alright.
No, sorry,
So
not half. 1. Tan inverse of 1 is 45.
so there is no half for tan.
There is, but it's not a very. You don't have to memorize it. Okay. Let's see what it is. Tan inverse of half is.
Oh,
No, sorry.
so,
Yep, it's 26.5 something, right?
yeah.
So we don't have to memorize that. But if I say tan inverse of 1, what is it? 45.
45.
Exact.
Alright.
So you have to memorize that. So tan 1, therefore tan 1 is always 45 degrees. Sorry. Tan 45 is always 1. Okay. Let's continue. Now the next thing you have to look at is, now you know what the sine rule is. The functions are, right? There's no doubts in that. Can we look at
No.
the next topic? Okay, now the next topic
Yeah.
is about the graph of these people. Now, okay, but not before the graph, let's look at the area of a triangle. Area, we have found the length of a triangle, but we'll have to also find the area of a triangle. Area of a triangle. So let's first make a triangle. Let's say a very weird triangle like this. Or let's make a right angle triangle first. Now this is your right angled triangle. Why is it a right angle triangle? Can you tell me?
Because it's a square on the left hand side.
Not really a square. This angle right here is 90 degrees. Is that clear?
Yeah.
So always 90 degrees.
Alright.
Okay, so if I try to solve this, now it's always 90 degrees, so that's a right angle triangle. Okay, fine. Okay. Now this is right angled triangle. Fine. And the area for this, the area for a right angle triangle is how much? Half BH. This is B,
Yeah, I know this.
this is H. You know this, right? Easy. Now the next one is, what if you don't have a right angle triangle? What if you have a triangle like this? How do you find the area? Now if I tell you that, let's say this is 6,
I think you
or
take it from the middle to the bottom.
let's say, let's see. If I have, and B here. Okay. Now if you have a triangle like this, you have A, B, C, corners A, B, C, and side A, B, and C. And if you have to find the area of this, it is always half AB sine C, capital C. Now let's see
Alright,
which of
so
these.
every triangle that's not a right angle triangle, we have to find it like this.
Yes, always, right? Make sense?
Alright.
Good. That's a formula, or yet all you have to do is just plug in the values. That's easy. Now if I just give it some color coding, this is the C. The corner C, right? This angle C. This angle right here is
Yeah.
the angle C. Here.
Oh, so we do the capital C.
Cap, not not small side, not that one. Okay, and the other one is, let's see, which A are you going to use? The side A.
Wait,
Small
so I have
one.
a question.
Ask me, yeah.
First, we find the I don't know. Wait, I forgot the trigonometry
Theta.
thing. The answer by using
Yeah.
the theta,
Yeah.
and then we use sine on the theta, right?
Yeah, but we can't do sine theta over here. Why? We can't find theta because this is not a right angle triangle, is it? Now, the trigonometric functions only work for right angle triangles, RAT, but not for these. These are not right angle triangles. These are your normal triangles, which are not right angle triangles. So, let's say in this case, let's say, what is opposite to theta? Which side is opposite to theta?
C.
C. So can I say sine theta is, which is adjacent? What is the hypotenuse? Can you tell me?
It's A.
A. But the thing is, it's not A. C and A are exactly the same.
Wait, you asked for the adjacent, right?
Adjacent. So which is the hypotenuse in this case?
Hypotenuse, the hypotenuse B.
B. Okay, if I say, but the problem is, you only have, okay, let's say, there would be opposite by hypotenuse like this, right? But this is wrong.
Mhm.
Why? Because this is not hypotenuse. And this is not, this is opposite, okay. Opposite, fine. But this is not the hypotenuse. So why? Because hypotenuse is only for right angle triangles.
Oh,
Okay.
okay.
So if you don't have a right angle, you can't use this. So this whole thing is wrong. Fine. So you can't use sine functions or cos or tan in this triangle. You can only use it in this one, the first one. This one, 1, 2. Okay. Now, but let's try solving some questions, shall we? Let's do that. So just a second. Question 1. Now the first question says you have a triangle like this and like this. Now I tell you, in the question you will be given the angle. So let's say it's 60, and you have been given the side 5 and 3. Tell me the area of this triangle.
The area of triangle. So the angle is 60 degrees.
Okay, yeah, it is 60. Yes, fine.
Alright. So you do
What is the formula?
half
Half.
AB.
What is A? So first, before you start solving, let's first write the names of these sides, shall we? Let's say this is C. Now angle is always the C one, right? It has to be C.
Alright.
So the other one should be the small c. Okay, the side C, the corner C. Okay, therefore then the next thing is, let's take, we can take this as A, or we can also take this as A. What would you prefer, the top one or the left one?
The left one.
Left one. So A, and this is B. So therefore this is small b, this is small a. The side A, this is the corner A, corner side. So what we do is,
So it's opposite. It's kind of opposite to each other.
which are the, yeah, it is always opposite. It's not kind of, it is opposite. So side A is opposite to corner A. Side B is opposite to corner B. Side C is opposite to corner C. In this case, what we take is we take side C, side A, side B, and sine of corners capital C. Half side A, side B, sine corner C, the angle C.
Yeah. So
What
we do
is
area equals 1/2 into 5 into 3,
into?
which is 15, and half of 15 is
not really. First write the
7.5.
whole formula first. Let's write everything down first. What comes after this? Sine
Sine C.
60. What is C? 60.
60, yeah. 60.
Okay. Now we can solve this. So 15 over 2 into sine 60. Now
So
I told you
5 into 5.
what sine 60 was, right? Let's look here.
Yeah, yeah.
What is
It's
sine 60?
sine inverse 1/2.
So therefore sine 60. No, it's not.
Yeah, 1/2.
No, it's not half. Why? It's sine 30 is 1/2, not sine 60.
Oh.
It's very easy to confuse. Cos 60 is half, not sine 60.
So is it 1?
So we can't do that. We'll have to use the calculator then.
It's not 1?
It's not 1, no. It doesn't double.
Oh,
It doesn't work like that. Let's look at the calculator. Now, so sine 60, sine inverse of, just a second, sine 60 is equals to root 3 over 2. What is it?
Root 3 over cube, like over 2.
2. Sine 30 is how much? Half. Okay.
So
What is sine 60?
for?
Sine 60 is?
What is the decimal? We don't care about the decimal.
We don't care about the decimal.
3 over 2. Oh, okay.
3 over 2.
3
So root 3 over 2. Now let's see. What was sine 30?
1/2.
1/2. Okay. So sine 30 is 1/2 and sine 60 is root 3 over 2, right?
Yeah.
Now let's switch it up. Let's say cos 30. What will this be? Root 3 over 2. And sine 60 is half. Is the opposite.
Oh, okay. Yeah.
Make sense?
Yeah.
So let's write it above here. Let's write it here. So sine 30 is half, and sine 60, comma sine 60 is root 3 over 2. Is that clear?
Yep.
Therefore, what is cos 30?
Root 3 over 2.
No.
So 1/2.
Yes, sorry. It is. Yep. One. It's not. It is root 3 over 2. So is that clear?
Yeah.
Okay, let's continue. So in this case, we have sine 60. So this will be 15 over 2 into root 3 over 2.
Okay.
And the answer is 15 root 3 divided by 2 divided by 4. Is that clear?
Yeah.
Now there's one thing
So we
missing.
can solve this.
We can. Tell me, Anas, what are you saying?
Can we solve this? Like, can we simplify it even,
No, we
even
cannot.
more?
We can try to,
okay.
but 15. We can't divide 15 by 4, right? But what if it was 3?
Yeah.
If this was 3, this would divide by 1, 5. But
So we
it's
can
not
multiply 15 to the
root
root 3, right?
but it will become a decimal, right? We don't want a decimal. We want fraction.
Yeah.
So always fraction over decimal,
Okay.
right? Now, one thing which is missing is area will always be cm squared, or let's say km squared, or cm squared or km squared, right, in your syllabus. But have they told you what is 5? Is it cm or km? Or meters? Have they given the units for you?
No.
No. So if no units, we just say whatever the units are, we square it. Units squared. Is that clear?
Yeah.
So unit squared. Next
So
question. Yeah.
Don't give a unit in the exam, like if
Right, unit
it's
squared.
just a practice test. If it's just a practice test and they actually forget to give the units, like by mistake, so do we just put?
They will not forget, actually. They will actually intentionally not give you the units. They will not give you the units, and they will expect you to write this. You have to write this in the exam. Okay? This is for 1 mark.
Alright.
This unit squared. So they will not give you, they'll just say 5 and 3. And then they'll ask for units. What is a unit? Unit squared. Okay?
Unit square. Yeah.
So in this, let's say another one. Let's take a very weird triangle. Let's say something like this. Now I'll give you the theta, which is, now what if instead of giving you the theta, this is the theta, right? And I'll say this is 5 and this is x. Let's say this is 15 and this is x. And I'll tell you that the area of this triangle is 150. And you have to find what is x. Solve the question.
150 equals
150 equals
15 plus x, I think.
Plus or not plus, multiplied. All of it is multiplied.
Oh,
X
okay. Multiplied by x
into sine
into sine c.
C. What is C right now? Theta?
The theta coordinates.
Theta. So we don't know what it is. So we'll just write theta. We don't know. We can write C or theta. We're just trying to find the unknown. We are trying to find what the number is. So 50 divided by 15. Wait, sorry. No, that's wrong. This question is actually wrong. You can't solve this. Let's say this is 5. Now you have to find what the theta is. Now can you solve this? So this side is 5. So 150 is equals to 15 into 5 into sine theta.
So we do 150 equals 15 into 5.
Yes. So 150 divided by 15 into 5 equals to sine theta.
Yeah, sine
Theta. So now we can cancel this and this. This will become 10. This will become, okay. If you cancel this again, this will become 1. This will become 2. So sine is equals to 2 is equals to sine theta. So what is theta?
2.
What is theta? We know sine theta is 2. So no, it's not. That's not theta. No, wrong. How do we find the angle theta? We take this to the other side. It will become
Okay. Sine inverse 2.
sine inverse 2 is equals to theta. Right. Yep. Let's try it. Now I doubt you'll get a correct answer because this is a question which I created in my mind. Yep. Okay. So let's switch some things up. Let's say the area is actually 70. Let's say the area is 25. 37.5. If the area was 37.5, now what will we do? We'll just take these guys again to the other side. It will be said 37.5 divided by 15 into 5. But this answer will change. So what is 37.5 divided by 15 into 5? That's 1 over 2. Okay.
1 over 2, right?
So the then sine is, what is theta?
Sine, so 60.
Sine inverse of half, and that is?
60.
Are you sure? $30, not 60.
30. So
It
cos
is
is 60, right?
cos is 60, yes. So you can memorize cos is 60, cos is 60, cos is 60. Then therefore if cos is 60, then sine would be 30. And therefore if cos 60 is half, then cos 30 must be root 3 over 2. Okay, so that's any doubts in this question?
No.
Let's can we move on to the next topic?
Yes.
Okay, good. So it's not hard, right? It's you are understanding, right?
It's easy. Pretty easy.
Pretty easy. Sine rule. Now you have sine rule. What is sine rule? What is sine rule? That's sine rule is that a. First, let's get our handy triangle over here. Just a second. Let me try if I have it. No, I don't. I'll make one for you. Just a second. Let's use this. Now again, sine rule is.
Is this a right triangle?
This is not a right angle triangle. No.
Oh, okay.
Okay, so this is not a right angle triangle, right? This could be any theta, theta 1, theta 2. But let's name them in a different way. Let's say A right here, B and C. This is C, this is B, this is A. Now the sine rule says that sine A over A is equals to sine B over B is equals to sine C over C. Is that clear?
Yeah.
So sine, what is A? A is the angle A. So if you take sine angle A and divide it by the side opposite to it, sine A, right? They're opposite to each other. With that will be equal to the sine B opposite side B, sine C opposite sine C, side C. Let's try solving a question on this. ASAP. Just a second.
Yeah.
Question 1. Let's say you have A, or let's say you have 5, you have 30, you have 60. What is X?
So you do sine A.
What is A? So sine what? Sine A. What is A?
A is 30
30. Okay. Divided by
divided by 5
is equals to,
is equals to sine B.
what is that? I need the angle, not the letter.
Oh, the angle. I don't, there's no angle for sine B.
So no. Okay. So but the thing is, you don't have to take all of them. We only care about, let's say you have C.
Yeah. I hear you right now.
Yes, can you hear me?
Your voice is loud.
Now can you hear me? Now can you hear me? Now can you hear me? Tell me. I can't hear you. Nope. Now try speaking.
Wait, can you hear me now?
Now I can hear you. Perfect. Let's continue this. Now, you have the angle C. Let's just give the letters quick. So this has to be A, B, C. Small c, small a, small b. Now we're trying to find C. We don't care about B. There's nothing given about B, so forget it. Let's just focus on C. Now sine C,
Okay.
which is 60, so 60 divided by x. So what is x?
I don't know.
So first tell me, what is sine
So
30?
we do sine 30. Sine 30 is
Half
1/2
and divided by
by
5.
5.
And what is sine 60?
Sine 60 is
Root 3 over 2. Okay, tell me, what is it? Root 3 over 2. Remember it. I won't be telling you
Okay.
always, so you have to remember. Okay. Now how do we solve this? Take 5 to the other side and half x to the other side. So half x is equals to root 3 over 2 into 5.
Yeah.
I can take 2 to the other side as well. This will become half x is equals to root 3 over 2 into 5 into 2.
So 5 times 2
Cancels out.
10.
5, the answer is 5 root 3. Any doubts?
Okay. No.
Easy. Let's look at another question like this.
Yeah.
Question 2.
So how does how does 2 cancel out?
Because 2 is in the denominator, which is being divided, and this is being multiplied, right?
Yeah.
So what is half into 2? Tell me. Half into 2 is 1. You can remove this, and still 1 is equal to 1.
Okay. All right. I get it.
Get it? Good. Now don't be afraid to ask me questions. Let's ask me questions thrice, 4 times, 5 times, until you understand. Don't say yes, I understand for no reason, because that's useless. Okay? So unless you understand, only then you should say I understand. Okay, let's look at this question then. You have 5, you have 2, and you have 3. 30, 60, x, and y. Wait a second, y. I want you to find x and y. What is y? What is x?
So let's just start by marking them, marking the points. So A,
Right.
B, and C.
A, B, and C. A, small a, B,
yeah.
and C. Okay.
Now we do sine and then the capital A.
So tell me the angles. Don't tell me the letters. Tell me the angles.
Yeah, sine capital A is 30.
Sine 30 divided by?
Divided by 3. No, y.
Y is equals to?
Is equals to sine 60.
60
by 2.
By 2 is equals to?
Equals to sine x by y. No, by 3.
3. Now what you have to do is, you can't solve all 3 of these together. So what we'll do is, Now, which one of these three does not have an unknown in it?
The middle one.
The middle one. So let's say groups of these. Let's take this group. So I need only one unknown in one group, one equation. So this has only one unknown, so I can solve it. And let's take another group of this one. Let's start with solving x. So if I try to solve x, it would be sine 60 by 2 is equals to sine x by 3.
3. So sine 60 by 2 is root 3 by 2 by 2.
Yep, exactly. And sine
And
x
sine x by 3 is.
If you take 3 to the other side, what will it become? So this will be.
It will become sine into that thing into 3.
3. Okay. Now if you solve this out, you would get root 3 over 4 into 3 and sine x again. How do we get 4? Exactly, good question. Now I'll take this to the other side. Just a second. This is, so these are some things you need to be good at. Root 3 over 2 divided by 2. Now can I put the brackets here? Okay. Now can I write this as root 3 over 2 brackets divided by 2? Can I do that?
Yeah. So the 2 cancel out.
It doesn't really cancel out. What happens is into 1 over 2, which is root 3 over 4. Rejoin the meeting. Now root 3 over 2 divided by 2, right? Can I write this as root 3 over 2 divided by 2? Same thing?
Yes.
Now these don't cancel out. Why? Because it's not being multiplied. They're the same thing. They only cancel out if this was multiplication, this was division. Division, multiplication cancels out.
Wait, do they also cancel out if it's like addition and subtraction?
Yeah, so 5, let's say plus 5 minus 5 is equal to 0. Cancel.
Oh, right? Okay, yeah.
But not in fractions. They don't cancel out in fractions. That's for when you don't have fractions. Okay. Now can I write this as root 3 over 2 into 1 over 2?
Yeah. How did you get the 1 over 2?
So we know whenever you have a fraction, let's say you have a over b, okay, which is being divided by c over d. This is the same as a over b into d over c. It's called the reciprocal. Reciprocal.
Yeah.
Reciprocal.
Okay, so yeah, I understand now.
Understand. So see, you're pretty good at this actually. You're pretty good. I'll compare to other students, you're very good at this. Okay. So root 3 over 3, so this will become 3 root 3 divided by 4 is equals to sine x. What is x?
3 root 3 by 4.
No, what is x? We have sine x. What is x?
Oh, so we do sine inverse 3 root 3 by 4 and then we get the x.
Yep, so use your calculator after this. 3 root 3 by 4. The answer is okay. Now you'll get the answer in the exam, right? You'll have a proper question. Now this question, I made it up. I made this question up, so it's not adding up correctly. So the method is the same, but in the exam, you will get an answer at the end. When you solve this in the calculator, you will not get math error. Is that clear? Why are you getting a math error? Because
if I solve it with the calculator, I will not get the marks.
You will not get math error. Now when I write this, look, 3 root 3 divided by 4.
I can't use the calculator right now.
No, you can use the calculator. You can't see it. Oh, sorry, just a second. Now can you see the calculator? When I try to solve sine 3 root 3 divided by 4, I get math error. Why do I get that? We'll talk about this in a minute. But in the exam, when you solve this, the method will be exactly the same. Is that clear?
Yeah.
Okay, now let's try finding y. What is y? We found x. How do we find y? Use the other equation. Right? You have to make groups of these. So we can use sine 30 and sine 60 over 2. Because all of these are equal. Since all of these are equal, I can make an equation of any two of the groups.
So if that doesn't work, do we do the next, like, do we use the new group?
Yeah, no, it will. So what are we trying to look in a group? This has 0 unknown, no unknown, right? No unknown,
Yeah.
and this has 1 unknown. Again, this has 1 unknown. So we're looking for an equation that only has 1 unknown. You have to make such an equation that should have only 1 unknown. If you have 2 unknowns, you can't solve it. Is that clear? So we
Yeah.
take no unknown is equal to 1 unknown, because then our whole equation, the blue group has 1 unknown only. The black group also has just 1 unknown. But what if I did this group? Let's say if I did this sine 60 and sine x. There's no way to solve this. Let's try solving it. Can we try? Okay. So sine 30 divided by y is equals to sine x divided by 3. Now if I try to solve this, sine 30 is half by y is equals to sine x by 3. Right? Is that clear? Now I'm trying to use the other group. And I'll prove it why you can't make a group like this. You can't make a group with, or an equation, not a group, an equation with 2 unknowns. You have x and y in the same equation. If I solve this, you get 1 over 2y into 3 is equals to sine x. Therefore, sine inverse,
1 over 2 divided by y.
so 3 over 2y.
Wait, isn't it 1 over 2 divided by y?
Yeah, but that's when you solve this, you'll get 1 over 2y. 1 over 2 divided by y is the same as 1 over 2 divided by y is equals to 1 over 2 into 1 over y, which is 1 over 2y. Okay?
Yeah, okay. Yeah.
So, but now, can you tell me what is sine inverse of 3 over 2y? You can't, because
No.
y is unknown. We don't know what y is.
unknown.
Yeah. So you should make a group of the other one. Sine 60 by 2 is equal to sine x by 3. Yes. No, unknown and known. Okay. Let's try another rule. The next question is, any doubts in that question?
No.
Right. Let's look at the cosine rule. Now, cosine rule is, it's pretty easy, same thing. Make a triangle. By the way, Anas, we have finished 80% of your syllabus for trigonometry, or 90%. When we finish this, it will be 90%. So it's not really difficult, is it?
No, it's pretty easy.
Okay. Now we have A, B, B, angle C and side C. What we know in this is that if you try to solve this, we will realize that cos A, or just a second, A squared is equals to B squared plus C squared minus 2BC cos A. Is that clear?
Yeah.
Or a better way to write this is, again, the Pythagoras theorem. What is the Pythagoras theorem? Tell me. C squared is equal to...
C squared equals A squared plus B squared.
Now we do one more thing. After this, we'll add a few lines. C squared is equal to A squared plus B squared minus 2BC cos, sorry, minus 2AB cos C. Is that clear?
Yeah.
Now this C and this has to be same. I can write this in another way, but just a second, C and these have to be the same. Okay. Now if I write it in a different way, I can say A squared is equal to, what will be over here? B squared plus C squared minus 2BC cos of
A.
capital A. Then in the same way, if I say b square is equals to c square plus a square minus 2
minus 2ab
ac cos
ac cos c because b.
b. Right? Any doubts in this?
No.
Fine. Now in this way, you don't have to memorize these three. Forget these. They are correct, but you have to memorize this only. This is the important one, the first one, okay? It's much easier to understand, right? Why? C square plus a square plus b square, that's your c square is equals to a square plus b square, that's your Pythagoras theorem. All you have to do is minus 2ab cos c, right? That's what we did here. Now it's kind of similar to half ab sine c. But in this case, it's not half, it's only minus it. Instead of half, it's minus 2ab sine c. Okay.
All right.
Now, if I just saw one question ASAP, question one. I'll give you some assignments to practice all of these in the next few days. And until the exam, you'll be perfectly ready. So just a second, let's say 5. Yeah, you know what 5 is? You know what 3 is? Okay, let's see. You have to find what is x. Can you use sine rule in this? First try using sine rule. And let's try using sine rule.
Sine rule?
Yeah.
Oh, so I do I do like the c squared equals a squared plus b squared or something else?
That's cosine rule. That's the cosine rule. What was the sine rule? The one we did before this. The one we did before this was that sine rule is sine a by a is equal to sine b by b is equal to sine c by c, right?
Oh, yeah.
Right. The thing is, you can only find these two if you know an angle and an opposite side, right? You need to know an angle and the
Yeah.
opposite side. So I'll just write it here. Can only use sine rule if we know an opposite side and angle. Wait. An angle and opposite. Read this, Anas, ASAP.
So can only use sine rule if we know an angle and the opposite side.
So if you don't know an angle, let's say if you don't know what C is, the angle C, and if you don't know what the small c is, if you don't have a pair, let's say A or B, then you can't use this. Now in that case, let's say we don't have any sides here which tell us the angle and the opposite side. Because over here we know angle, but we don't know the opposite side. We know the side, but we don't know the angle. What is the angle here? We don't know the angle here. So
Yeah.
what rule will we use? Use cosine rule.
Cosine rule, all right.
Now the first step always Anna says to mark the angle, right? So let's first mark it.
So we do A, B, C, and then lowercase a.
Done. Now how do we solve this? Tell me the Pythagoras theorem first. C square is equals to a square plus b square. Then we just add, after this, the Pythagoras theorem, we add minus 2ab sine c. I use this to solve the question.
Okay, so c squared is x squared.
Okay.
Equals a squared. So a squared is 5 squared plus 3 squared minus 2 into 5 into 3 sine 60.
What is sine 60?
Because the sine is 60 degrees.
Yeah, I know, but what is it? What is the value for that?
See?
Sine 60 is root 3 over 2.
Oh, okay.
Now, pi square is 25 plus 9 minus 2 into 10 into 3, that's 30 into sine 60, that's root 3 over 2, right? Okay. Now 9, this would become 34 minus root 3 by 15, sorry, 15 root 3 is equals to x squared. What is x? X is all of this under root. Any doubts? And if I try to find the answer,
No.
it would be
Wait,
34
why did you put the 2 over there?
because it's squared. It's a square root. Because it was 2 over here, when I go over there, it becomes 2. Okay?
Oh, so is it important to put the 2 over there? Or?
You can, but it is only important when, let's say, we have 3. If instead of cube
Oh,
square,
okay.
we had cube. Now if I take cube over there, let's say if I take cube over there, it would become cube root. So you can put the 2.
All right.
I would like you if you put the 2. Okay? So if this 2 goes there, this will become, the square will become square root. Okay.
Yeah.
So then
I
the
get
answer is root 5 into 3, 2.83. Let's say
it.
318. So 3SF is
3.0.
no. If you have this answer right here, how do you write this in 3SF? 2.83. Three digits from the right. 3 digits. So 1, 2, 3. So 2.83.
Right.
Okay. Now that finishes cosine rule. Now we have one last thing. Can we finish this?
Yeah.
So let's look at the graphs. This is the last thing in your syllabus. Then trigonometry is done. There's nothing else in the book. A graph. Look at the graphs of again sine sine theta, or let's say sine x, cos x, and tan x. There's nothing different. There's no difference between cos x and cos theta. They are the same, right? No difference. X and theta are the same thing. Same. Okay. Now if I look at the graph of sine x, how would it look like? Let's first make our axes. Have you done graphs in school?
Sorry.
Have you done graphs in school?
Right now?
Have you done graphs in school? Have you finished it? In school?
I don't know.
Okay, never mind. No, it's okay. So if you have two axes. What are these called? Axes.
Yeah, actually.
Have you done this before? Do you know what graphs are?
Yeah.
Okay,
Isn't
good.
it AXIS?
Yeah, okay. AXIS. Well, that's for this. That's for this. That's for this, right? Axis. X-axis.
Yeah.
But if you take a multiple plural, that's this is singular.
Oh, okay.
Then it becomes axes.
Okay.
Right? Okay. Now, if you're writing just one, you should say I. But if you're writing about two, we write axes. So I'll say draw axes. So draw both the axes. That's the first step.
All right.
Second step is mark reference values. Which values? Reference values. What is the meaning of reference? What is the meaning of reference?
Reference? Is it like referring it to someone like?
Example. Or yeah, referring it to someone, or to for example. Let's say taking, or to, let's say, to refer to points, right? It's to showcase or look at. as an example. Now, in sine rule, in sine, you have to look at 1. Always let's just draw 1. And the other one is -1. And the other things we'll draw is a few things. We'll draw just a second. Okay. We have 90 degrees and the x-axis, then we have 180 degrees, then we have 270 degrees, and the last thing which we have is, okay, Anas, what do you get if you add 90 to 270?
90 to what?
90 to 270.
270 or add it or into like
Add
multiply?
Add, addition.
36.
360, right? 36, 360. Now, so you have to write 90. What is this? This is plus 90. If you
Yeah.
add 90 to this, again 90, again 90. Fine. Is that clear? So we're just adding 90.
Yep.
And this is 0. Write 0 as well here. So this is plus 90. Okay. Now, one thing you need to know is these sections are called quadrants. From here to here, these are called quadrants. What are they called?
Quadrant.
Quadrant. Why are they called quadrant?
Quadrant.
Why are they called this? Because quad means 4. And we have first quadrant, we have second quadrant, third quadrant, and fourth quadrant. Now let's remove all of this for a second. You don't need to know this one right now. You don't have to focus on this. What you need to focus on actually is the shape of the graph only. Okay. Now let's look at this. What is the first step? Anas, first step.
Draw axes.
Second step.
Mark reference values.
So the reference values are 1, 0, -1, and 90, 180, 270, 360. Is that clear? These are your reference values. Now the next thing is we'll look at the graph of sine. This is what it looks like. Is that clear? Anas, can you hear me? Muted.
Yeah.
Okay, now this is the graph of sine. Is that clear?
Yes.
So this point right here will always be at 1. 90, it's at 90, it's 1. At 180, it's 0. At 270, it's again it's -1. 360 is 0. Right? So all you have to do is make 4 points. Make 4 points like these. 1 second. How do you draw this curve? How do you draw this? I'll show you how to draw. Just a second. Put the 4 values. So at 0, it's at 0. At 390, it's at 1. At 180, it's again 0. Then -1. Then here. All you have to do is join these points.
Okay, it's easy.
Easy? Yep.
Yep.
That's all the mark is for. Now the next thing is cos graph.
Was
This line,
this the sine graph?
tell me, say that again.
The graph we just did, was it the sine graph?
Yeah, sine graph, sine x.
Sorry. And this is the cos.
This is the cos one. Now again, what are the reference values? 1, -1,
1,
0,
-1, 0.
again 90,
90 degrees, 180 degrees, 270 degrees, 360 degrees.
See, that's so easy. I mean, it's easy for you. For others, it's not really easy. But for you, it is. That's good. But I don't want you to think this is easy. This is actually pretty difficult. And you have to practice. Okay. Let's make the graph.
Right.
This one starts at 1, goes down. So the values you have to, the points you have to make are this. At 0 it's 1, at 90 it's 0, at 180 it's -1, at 270 0, then here.
All right.
And this is what it looks like. Is that clear?
Yeah.
Now the final thing is, we're almost done, the tan graph. The last thing in our class. Tan graph.
What are these graphs used for?
Okay, what are they used for? Okay, let's say, okay, Anas, if I ask you, what is cos 90? Can you tell me?
0,
0. Easy. What is cos 270?
cos 270, 0.
0. So you can guess. It's to show it where are the values and where are they, right? You can find the values. Now, there's a lot more
Right.
uses. There are a lot more uses, but not right now. It's in class 11. Right now, you just need to know how to draw them. That's it.
So if it's in the exam, then we just draw it. Did it
Yeah.
just ask you to draw the graph?
Just draw it. Yep.
Oh, okay.
Now it's just pretty easy. IGCSE is actually pretty easy. Just practicing is the point, and I will
Are you,
be see. Practicing is my job for you, right? I will make sure you practice. You don't have to worry. Now, are you saying something?
yeah, are you in university right now or A level?
I'm in university, right? I'm doing masters,
Oh, so okay.
right?
So you are is the university or India or out of the country?
Out of the country.
Yeah.
I told
So
you it's okay. Yep, out of the country. Now let's focus on the graph. The thing is, I did IGCSE as well. I got all A stars in IGCSE, a very good marks in A levels as well, in class A levels, right? 11, 12. I got 97 in computer science, same in every other subject. Okay,
mashallah, that's great.
let's look
That's
at the,
my goal to get a high score.
inshallah. That's my goal for you as well, because if you're studying under me, it's my job that you at least get all the A stars. But A stars are not enough. You have to be India topper. Is that clear?
Yeah.
India topper. Now, just a second. Let's draw the tan graph. This is what your tan graph looks like. But so drawing it for me would be a bit difficult, so I'll just show it here. Look.
Oh, okay. So there are multiple numbers in a tan graph.
Yeah, it's a big range. So just a second. I'll actually draw it for you. Just a second. Again, but our reference values will be a bit different for this. They won't really be the usual ones. They look a bit like this. Just a second. Now we know that tan 45 is 1, right?
Yeah.
And we know that tan 0 is 0. So I'll tell you how it looks. 1 second. This is how the graph looks. There are a few reference values. The reference value are again 1, -1, but they don't stop here. This graph will go onwards. The sine stops at 1, and even cos, but this does not. Just a second. We're almost done. Fine. Okay. Now let's remove this for a second and take that right there. Okay. Now we'll again put the same values, but right now instead of that we'll put 45, 45, 90, 180.
180.
Again, so this, okay, just a second. 90, 180,
So we just leave some space for
half
the
for
multiples
45,
of 45.
45, the
Yeah.
90 plus 45. Okay, we don't have to write it. We just put space
Okay.
for that. Now this would be 270 and then space again 360. Fine.
So this we have to also learn how to draw this.
Yes. This is the final one. The final boss battle, right? This is the final one. So at 45 it's 1. At every 45 multiples of 45 it's going to be 1 second. It's not always that. At this place it's -1. At this place it's 1. At this place it's -1. So it's alternating. At 45 it's 1. At 90 plus 45 it's over here. In the same way, if you go backwards, you also have to go backwards. So -90, and again over here 45. At this 45 it's again -1. So it's alternating. -1. Okay. Now the final thing is join all of these points together. And this is what it looks like.
So for minus, do you go all the way to -360?
Not always. Yeah, always 360, right? Yes. -90 to 360. Unless they say something else in the question. Now just a second, this is what it looks like. Actually this is wrong, just a second. Not actually wrong, never mind. It's okay. So it looks like this. Then just a second. It comes down like this, then bends. Just a second. And that's it. That's it. That's how it looks. To look at the proper shape, this is how it looks. So it will always pass through. At 45, it will always be 1. At 90, it will never touch. So it will never touch 90. It will never touch 90. Is that clear? Never touch, and it will also never touch 270. And it will never touch -90 either. Now these lines, these red lines, are called asymptotes. That's the last thing in our class, and it's done. Asymptote. What is the meaning of asymptote? A line that is never touched. A line on graph that is never touched. Touched. Okay. By graph. A line that is never touched by graph. Done. That's it in that's everything in trigonometry. We finished the chapter. Now I hope you practice the questions in your book. I'll give you an assignment later. Okay, now just wait for a second. Tell me, what have you studied in this class? Recap.
We learned about the trigonometry functions. I think that's what it calls.
Yeah. Trigonometric functions.
And then we learn about sine. In the trigonometry functions, we learn about sine, cos, and tan, and you could also refer to this as saw something.
Sokatua. Soka.
Yeah, sokatua. Sokatua. So yeah, and we learn about how to find the area of a triangle with in trigonometry.
Yep.
And we learn about the graphs.
Graphs, okay, and the cosine sine rule. Now all you have to do is watch this recording over and over again. If you have any doubts, ask me. Now just one last thing, that is, if you have any friends, Anas, you have any friends in school who would want to join with you?
I don't know. I don't have any friends right now.
Not right now. Okay. So if you know anyone, let's say your family knows someone who's taking IGCSE or anyone, ask them to join us, please. That would help us out. So take care. Khuda Hafiz.
Okay.
Allah Hafiz.
Allah Hafiz. Allah Hafiz.